we need to simplify the following. So we'll take the help of De Moivre's theorem, which states that whenever we have cosine of theta plus iota times sine theta raised to the power of n, then that becomes equals to cosine of n theta plus iota times sine of n theta. Now, here we have the real part, a sine function, and the imaginary part is the cosine function. But in order to apply the De Moivre's theorem, we'll need the opposite. That means we'll need the real part to be the cosine function and the imaginary part to be the sine function, which would mean we'll need to simplify the expression within the parentheses. So let's begin with that expression. We will start with sine pi over 6 plus iota times cosine pi over 6. So this is equals to, we'll take iota as the common factor. So that means we have cosine of pi over 6 plus 1 over iota times sine pi over 6. Right. Now 1 over iota can be also expressed as iota raised to the power of 4 divided by iota, because we know that iota raised to the power of 4, that value is equals to 1. So we are using this particular fact here. But this means we have iota cube, and iota cube, that value is negative iota, meaning 1 over iota is also equivalent to negative iota, which becomes an iota multiplied to cosine pi over 6 minus iota times sine pi over 6. So this is the value of sine pi over 6 plus iota times cosine pi over 6. Now since this value is raised to the power of 7, so let's raise to the power of 7 on the expression on the right hand side, which will give us now I raised to the power of 7 multiplied to cosine of pi over 6 minus iota times sine pi over 6 whole raised to the power of positive 7. Now iota raised to the power of 7, so this is equals to iota raised to the power of 4 times iota cubed. Iota raised to the power of 4, that being 1, we have iota cube, which is negative iota. So we can replace iota raised to the power of 7 with negative iota. Now what we'll do, we'll have cosine of pi over 6, which can be also expressed as cosine of negative pi over 6. This has been done so that we can absorb this negative sign into the sine function. We have positive sine of negative pi over 6. Now this can be done because our cosine is an even function. So that means whenever we have cosine of negative theta, that's simply cosine of theta. And when we have sine of negative theta, that means we have negative sine theta. The reason behind this is that sine is an odd function. Now this has been this is raised to the power of 7. Now this has been done so that we can multiply 7 to negative pi over 6 to get negative iota. So here we'll be applying the De Moivre's theorem. So we have cosine of negative 7 pi over 6 plus iota times sine of negative 7 pi over 6. Right. So now we have successfully applied the De Moivre's theorem. Our next task will be to solve the value of cosine of negative sine of 7 pi over 6 and sine of negative 7 pi over 6. So let's do that. Now we'll start this side. So we have cosine of negative 7 pi over 6. We can again use back and convert it back to cosine of 7 pi over 6, which will be equals to cosine of, so 7 pi over 6 can be also expressed as pi plus pi over 6. Now cosine of pi plus pi over 6 means this becomes equals to cosine of pi over 6. Now pi plus pi over 6 means we are in the third quadrant where the cosine function is simply negative. So we have negative sine pi over 6. So that means we will now have negative iota times cosine of pi over 6, and this is equivalent to cosine of negative 7 pi over 6. Now coming to this other one, so here we have sine of negative 7 pi over 6, and this is equals to negative of sine 7 pi over 6, which is equals to, so this is negative cosine of 7 pi over 6. So here we have negative of sine pi plus pi over 6, which will be equals to negative of negative sine pi over 6, which gives us the value sine pi over 6. So this is positive. So we have positive iota times sine pi over 6. Now we'll multiply negative iota to each of the terms. So we have iota times cosine of pi over 6 minus iota squared times sine pi over 6. Now iota squared, this value is simply negative 1. So that means we have positive sine pi over 6 plus iota times cosine of pi over 6. Right. So we can now finally substitute the value. So sine pi over 6 is the 1/2 plus iota times cosine pi over 6, that's square root of 3 over 2. So the simplified value of this particular expression is going to be equals to 1/2 plus iota times square root of 3 over 2.